Now we have to define the input signal U to our system. For this, let's open the group entitled Sources. In the library, here we have Sources. And let's copy the generator, the step generator to our model. And in addition to this one, also this block entitled clock, which is the generator of independent variable. This is time. Now we can connect the step generator with the input of our system, and we can define here step time. Let's say 1 is okay, initial and final value, which is by default set it to 1. We can leave these default values unchanged. Now we have to define how we are going to observe our simulation results. Two basic possibilities are available. The first one enables the observing results during the simulation run, while the second enables the usage of the results after the simulation run. For this, let's open first the group Things in the library and copy the block XY graph into our simulation scheme. Let's open the communication window of this element, and from this it is possible to find out that we have to connect the first input with the time generator and the second with the signal we would like to observe. So let's plot the connection with time generator, and let's connect the second input with the output of our system. Let's open again a communication window, and here we can see that we have to define the range of independent variable. This is time, and let's choose the range from 0 to 10 seconds, for example. And for dependent variable, the range of this variable is going to be from 0 to 1.2. Sample time can remain -1, as it is going to be inherited from the step generator. Now we can save our file as for example, let's choose the name sim model, and the extension SLX is going to be added by Simulink, which means that this is going to be a simulation model. Click Save, and we can see that this file has appeared here in the current folder. Before starting the simulation run, it is important to inspect also the simulation parameters. For this, click on the simulation, and here we can choose the possibility model configuration parameters. Here we can observe all the parameters of the simulation. For example, we can define the simulation time. We can choose the solvers with variable or with fixed step. In our case, variable step is a better solution. We can choose between different integration methods. We can define relative and absolute tolerance, and so on. Well, in our case, we can leave all these parameters as they are proposed by default. Let's click OK. And now we can start a simulation run. The simplest way is to push the green button with black arrow in the upper menu. This starts the simulation run, and during the simulation also the XY graph draw our result. We can inspect this result in all the details.
It is frequently convenient to have simulation data available also in the MATLAB workspace. This can be achieved with the block to workspace from the group Things. Let's copy this block into our simulation model. By to click, I'm opening the communication window, and I'm going to change the name under which the selected signal is going to be saved in the workspace. And very important is also the format of the saved signal. One very corresponding or frequently convenient possibility is format array. If we are saving certain signal under this format, we will have, after the simulation run is finished, in workspace this signal available in the form of vector. We are going to need another 4 elements to workspace, so I'm going to make another copies of this element. One for time vector, one for input signal, one for the first derivative of the output signal, and one for the second derivative of the output signal. Now we have to connect these new elements to the signals in our simulation scheme. Time vector is available here. Input at this point. Output signal is the output from the second integrator. First derivative of this signal is here, and the second derivative of output signal is here. Now we can save the model with these new corrections. Now we can start the simulation run again. After the simulation run is finished, all the vectors generated by the blocks to workspace appear in the workspace and of course can be used. I'm going to plot, for example, an output and input signal generated by our simulation scheme. Let's say input signal should be in red, while I'm going to plot the output with the blue line. And here is our simulation result. Output in blue with respect to input signal, which is presented with the red color.